So we start by looking at the Pascals triangle, and we say that on any binomial expansion, the two key things that we're looking for are coefficients, and then two, it's the powers of the powers that you give the variables involved. So here we can look at the coefficients here, and then we'll look at the powers here. So we start here. Any number that you raise to power 1, power 0 gives you 1, isn't it? And any number that you raise to power 1 gives you that number. So here we've raised a plus b to power 1. So we're going to get ab. But the coefficients of ab are 1 and 1. Okay. So once we get these 3 ones, everything else can be made from there. So to repeat, anything raised to power 0 gives you 1. Anything raised to 1 gives you that number. Now here we're getting a plus b, a plus b. So here the coefficient is 1, there the coefficient is 1. Then all the other coefficients can actually be made from these, just by ensuring that you start with a 1, and then you add the next 2, and then you end in 1. The only addition is when you have two numbers. Okay, so here I can do that. I've got two numbers here. I can add, which is a 3. These two I can add, which is a 3. There's nothing else to add here, so I put a 1. Or you can see it as adding a 0. That space as a 0. We go to the fourth. We can say 1. Here we add, we get 4. Here we add, we say 6. Here we add, we say it's 4. And then again, 1 plus blank, it's 1. So we would have managed to get the coefficients. Even if you were to get to 5, 5 will be 1, and then 1 outside, then here 5, 10, 10, 5, 1. Just like that. It goes on like that. Pascal's triangle is efficient for, let's say, powers of 0 to about 5. After that, you're really just pushing the limit. Okay, so now here, let's look at how we get the powers. Okay, how do we get the powers? We get the powers by expansion. So here we said we are getting 1. There's no debate about that. Here we're saying that we're going to get a plus b. Right? How about here? When you expand here, you're going to get, first, you get the power from there. So you have 1. What is next? Next you have a. So all the terms are going to have a and b. So for example, let me do it from here. I'll get 1, which is this one. Then I'll get a b. I'll get both of the terms, a, b, just to give them a bit of space in between. Then we always start with the highest power here. That will give us the degree of the polynomial. So here we're starting with 2, okay, and then that will be 0. Then we go on to the next one, which is 2. So we say 2, again a and b, just given space. Then we are saying that we are descending. This one will descend, this one will ascend, like we checked in the previous video. So this one will descend to 1, this one will ascend from 0 to 1. And then this one will become, we get this coefficient here, then we get 1, a, b, spacing like that. This one descends from 1 to 0. This one increases to 2. So you see that finally, here 1 will disappear, 2 will remain, 1 will disappear here. So it will be a squared. What about this one? This one will become plus 2ab. What about this one? This one will become plus b squared. Okay, let's test this one. This one will become 1 as well. We'll start with the 1 here. Then a gets the highest power there, b gets the lowest, which is 0. Together, if you add, they still need to give you that. Then plus 3ab, like that. You can actually do all of them. 3ab plus 1ab, like that. If you are someone who forgets, then this one will descend. This one becomes 2, that one becomes 1, that one becomes 0. Then ascend this one. This is 0, 1, 2, 3. Then you simplify. Anything powered to 0 becomes 1, and then 1 as the coefficient disappears. So this is 1, which is a3, plus 3a squared b, plus 3ab squared, plus b squared. Right? Now we are going to look at the final one. Here we're going to say it's 1ab plus 4. So we're just looking at the coefficients. B plus 6ab plus 4ab, then plus 1ab as well. Okay, so what becomes of this? What becomes of this is that we start from 4, then we start descending. So 4, 3, 2, 1, a 0. Then here we ascend from 0, 0, because the total can only be up to 4. So it means that 4 plus 0. Don't put a 1 here. 1 can be there. This is 4. That's 4. 2, 4, 4. Then 3 plus 1 is 4. Then here we have 3. Okay, so if we were to simplify this, this will become AB, A4 plus 4A3B plus 6A squared B squared plus 4AB3 plus B3. That will be the expansion of AB power 4. Okay? Okay, so we've been given this to expand. It's not as easy as AB. So we just link it. We just create the equivalency here. And then we get the value. So we can say A is equal to 2. And then B is equal to minus 3x. So when we start our expansion, we said we focus on the coefficients and then the powers. So we start with the first one. The first will be that. Then the first term here is 2, 5. Then we said that it descends. In fact, what we can do is we do that. Okay. Then this will be power 0. Then we can go on and carefully just put the coefficients and the variables. Then we go to 10. We put 2. And then we put minus 3x. Then we put another 10. Then we put 2. And then minus 3x. Then we put 5. Then we put 2 minus 3x. Then we put our other term here, which is going to be a 1. And then we put a 2 and a minus 3x. Then we go on and put our powers. This is 5, 0. So this one becomes 4. This one becomes 3. That one becomes 2. That one becomes 1. And then this one becomes 0. Then we follow on. This is 0. That one becomes 1. This one is 2. This one is 3. This one is 4. This one is 5. Okay, so then we can expand this now. I'll just do one example. So this is 2 power 5. 2 power 5 is 32. Okay, but we don't have any x, we don't have any y, so that will just be 32. And then this one gives us 1, so we'll have nothing here since it's power 0. And the next term, I'll show you how I'll do this, then I'll do the rest. So this one will be 5 times 16. Okay, 5 times 16. Let me expand it here. So 5 times 16, 5 times 16 here, we get 80. Okay, and then this power 1 is minus 3x. We multiply these two, we get minus we get minus 240 by 3, sorry, x, because the power of x was 1 here. And so we can go to the next term. Let's not add it yet. Or we can, since we added it here, this is 1, 2, 3. So this is 8 times 10, 80. Now we're squaring here. So it means that we'll have a positive 9. And then here we'll have x squared. So together 80 times 9 is 720. And then we have a positive there. So it's plus 720 x squared. We go to this term here. That is 4, 40. This is 27. Okay. 27 times 40 gives us 1080. But then x is 3. So we have x 3. We proceed. These are simple expansions. We did these. So this is 10. Okay, 10. And we have 3 power 4, which is 27 times 3, which is 81. So 81 times 10. But then this is 4, so this will be positive. Okay, that will be positive. Here, we'll have a negative actually. Okay, here we'll have a negative. Here we'll have a negative. Okay. Then here, once we do those multiplications, we said we get x10, but h10, but then this will be x4. What about this expansion here? We know it's 0 here, but then this is 81 times 5, which is 243. But this is an odd number, meaning that whatever positive you create, at the end of the day, you multiply with a negative. So this will be minus. Okay. But then that's 243 x5. So you'll see that the expansion is quite easy if you follow simple basics. Get the right coefficients, descend the first term in terms of powers, the first variable, ascend the powers of the second one up until the end. Then the expansion is per term. It's not everything at once. Look at this one, expand it. Look at that one, expand it. And make sure you're keeping the powers. So you can see the powers x0, x1, x2, x3, x4, x5. So this is coming from the second term, which is here. Okay, all right. So this is the example that we have to do.